Okay, so welcome to the first session of a system software. This is for a third semester students, system software. So in the introduction class, I gave you the what you mean by the system and what is this subject about, why you need to study. Those are all the different things we studied here. So here we see with the accumulator and there is a loaders and linkers. These are all the different things that we will study here. So to understand the system software, first you have to pick a machine. Pick a machine for our trial and our error version. So if you are calculating the address and if you are calculating the mnemonics code, so we'll take a certain machine as a one of the model. So here we'll take a two machine, that is a simplified instructional computer SIC model and SIC bar XC, that is a extendable form. These machines we take it as a complete study for our further next in the syllabus for the next chapter. We see the with this machine structure only we will try to calculate the problems and then that address calculation we will see. So nowadays the computer it has become the Intel, that is the memory size, it will reach to several bytes, thousands of bytes memory address is there. So we can't deal with such kind of a complicated machine study, it is not there. So here for our purpose is to only main understand the concept, that is for simplification purpose we will take a small machine, that is a simplified instructional computer. So this machine, what are all its structure and instruction, those are things we will study here. First one is a memory. It contains the 2 to the power of 15 bytes of a memory in the computer, that is the maximum of a 32,768 bytes. See, compared with the nowadays computer, it's a very small. That's why we'll take it this one as for our study purpose. And the register is nothing but which stores several information. Okay, several information. So here 5 types of registers are there, each with a 24 bits long, 24 bits long register. So there are A, X, L, P, C, S, W. These are all the different register we have. So here for these register we give a number directly for calculation purpose. This one will come in the next sessions. For calculation purpose, we'll take this number as a standard. For address calculation, we'll take this number. So for A, it is number is 0 and we call it as the accumulator. This one we use it for arithmetic operations like addition, subtraction. For that purpose, we use this one. And X, which indicates a 1 index register. So this one we used for addressing purpose. L, the number is 2. Linkage register, this one we use it for a jump looping programs, in that one we use this L. PC, program counter, the number is 8. So for it will store the address of a next instruction to be executed, that is the PC. SW, the number is 9, we call it as the status bar. So this contains the conditional code, if statement, if else statement, those are statements it will be contain. So this numbering should be important. If they ask 0, what is the, you should know the mnemonics. If it is a 8, you should know the mnemonics, like that. And the data format. So data format is nothing but the integers, characters, floating numbers. So these are all the data types. Here how it will be stored and what is the size, that one we will see. So data format, integers, it is stored as a 24 bits binary numbers. Binary numbers nothing but zeros and 1. So what if it is a 2, we store it as a 24 bit 0 0 0 0. So 0 1 0, like this we will store the binary numbers. And this one is important, negative numbers we store it as a 2's complement of a particular number. If I want to store the -2, first one we will convert into the respective binary. That binary form, that one we will represent in the form of a 2's complement. So this will be understood that as a negative. And characters as a 8-bit of the ASCII code. So if it is a ASCII code of a capital A is 64. This one it will be converted to the respective 8-bit form, and that will be stored. And this one is very important. SIC machine, it won't support a floating number. That is the main disadvantage of this SIC machine. It won't support a floating number. This is about the data and integers and characters. So instruction format. So here we are studying with the in-between language, that is a assembly language we are studying. So assembly language, here we cannot write a C programs, printf, scanf, for loop, such kind of programming statements are there. So here we give a instruction. Instruction is nothing but which will ask the program to execute that kind of a code. So instead of writing a programs, we give instructions. Okay, add, load, such kind of instructions we will give. So that instruction, it should be on which format. The programs is different, and the instruction, while giving the instruction, in which format it has to be there. So that is the 24 bits long. This one is a opcode. So if I want to add, this is my add will be this opcode, and x is for if it is a direct address, it is a 0, and it is an indirect address, it is a 1, and the address. So I have to do the addition with the given address. Whatever the address we have given here, that instruction I have to do, and I have to add the code. So this is the format, 24 bits. Opcode is of 8 bits. X, which x is equal to 0, direct, and x is equal to 1, it is indirect, and the address. So this is the addressing mode also. Here we have a few problems and few instructions. That one we will see in the upcoming classes. For time being, understand 24 bits, 8 bit is for opcode, x is for direct and indirect, and the address. These are the instructions, not the programs. So continuing, I mentioned there are some problems regarding the instruction format. So in the last we have seen what's the instruction format of a SIC machine. That is a 24 bits long. 8 bits is for opcode, X is for index register, and the addressing is a 15. So this one, how it will be actually stored like this. In the whatever the instruction they have given, we have to write it in this particular format, and we have to find out the location. So we mentioned with the x is equal to 0 we have a different value, and x is equal to 1 we have a different value. Consider the example, load 10. So here LD stands for a load to accumulator. Now what we have to store, they have given the 10, but this is not actually the addressing value. With the instruction format we have to expand and we have to calculate it. So load, this load accumulator, load opcode is 00. This one you can find it in the textbook. Load the opcode value is 00. Now how we will expand here, observe here, 00 we have to write it in a 8 bits form. So 0 I will write it in a 4 bits, and another 0 I will write it in another 4 bits, so that complete will become a 8 bits. And if the x it is not given, we write it as a x is 0 directly. If x is given, we write it as a 1. If x8 is not there in the instruction, we write it as a 0. And suppose the 10, it is located in the address of a 1000. So 1000. So this is the effective address will becomes for this one. Effective address will be 00. This will be the 1000. This will be the effective address. What's there in the location 1000, that will be stored into the accumulator. What's there in the location 1000, that will be loaded into the accumulator. Now we'll see another with the indexed address, that is a x is equal to 1. STH, that is a store character. Store character, whatever there in the character, that one we have to store it into the buffer. So here you see in the instruction only they have given it is a x. So directly in the place of x, I write it as a 1. So 5, we told we have to expand into the form of 8 bits. 5 in the binary form 0 1 0 1. 4 in the binary form 0 1 0 0. And x, as they have given, we mark it as x is equal to 1. And suppose buffer, we started with the previous 1000 address only. 1 leave it with 1 0 0 1 0 0 0. Now combine this.